there's our question here. Can I get a brave soul to start here? We're special volunteers. Luke, go ahead. What's your points? You don't use 2,4, but if you want to, you can. I'm going to ignore 2,4. You can put it on there, and that's okay. We're missing one point here, though. He was missing here. Tristan, what do you miss? Okay, can you explain to whoever wasn't here yesterday what y cannot equal 0 is? What is that? No? It's the asymptote. Good. So to think here for 2 to the x, okay, right, you're never going to be able to have a 0 for a value because you're multiplying and dividing by 2. So if you take a piece of paper, which I'm going to do here, and I'm going to rip this up, will I ever get down to nothing? No, right? Mathematically, you won't. In real life, I would have like 2 elements to, try and disassemble at the end, right? But in mathematically, you'll get a smaller and smaller decimal, so it's never going to hit 0. The same thing, since these are positive numbers being multiplied and divided, you're never going to hit a negative number ever, okay? So there's your asymptote. Okay, great. Can I get a second volunteer? Luke, question or answer? No. Okay, here's the problem with negative 2 to the x, okay? The thing is, if you do negative 2 to the 1, it's negative 2. Negative 2 squared is positive 4. Negative 2 cubed is negative 8, positive 16. The problem is those in-between values, where are they? Like if you do in your calculator negative 2 to the 1.5, it's not going to work, okay, right? Because there's no in-between point. So those only work on the integer solution, so that's a non-continuous graph. So no, you can't for this. We'll just be using whole numbers for your base. Okay. All right, so you're right, the domain and range will be totally weird then, okay, for that for sure. Okay, can I get a brave soul other than Luke and Tristan to give me the first transformation, please? Yeah, go ahead.
By -3.
Very good. We're going to multiply y by -2. And again, for those who weren't here yesterday, we did this like tons of times through the first half of the globe. On the first unit test, we did tons of these, right? So once you get the first set of points, should be straightforward. So we're going to do here 0 and -2, 1 and -4, and y still cannot equal 0. You can put an extra point in there like we did, that's fine. Please make sure you include that asymptote. Okay, can I get another volunteer to do the second calculation, please? Go ahead.
So you have to divide your asymptote 1/3.
Good.
So
Sorry. Go ahead.
0 -2.
Yeah.
3 -4. And y
Very good. When you divide by 1/3, it's like multiplying by 3, right? So that's what I did there. So very good. So we have 0 and -2, 3 and -4, and y cannot equal 0. Now, once again, for people that weren't here yesterday, because y cannot equal 0 is just a line, whether you compress it or shift it, it's still infinite, right? The only thing that's going to factor is the transformation up or down. Okay, hold on.
Just like multiplying by 3.
No problem? Okay. So if you're doing 1 divided by 1/3, right?
Yeah.
That equals 1 divided by 1/3. 1 times 2 is 1.
Oh, okay, yeah. I get it.
So you're dividing by a fraction, right? That's all we're doing. All right, so I got a third volunteer for this one. -2f of 1/3 x minus 2. What do we do for the x values, please? Sorry, somebody do, please. Yeah, Bailey, go ahead. Good, so we're going to add 2 to x, good. And Lee, I'll pick on x. Okay, so we're going to add 2 to x, so that's 2 comma -2, 5 comma -4, and y cannot equal 0. Okay, hopefully these states we're doing it straightforward because we've done them lots this year. That's the dream. All right, Leo, what's the last one, please?
And then you're gonna add 6 to y.
Okay, so -2f of 1/3 x minus 2 plus 6, add 6 to y. Okay, now I'm just going to yell for a second, if you don't mind me yelling. Okay, I'm the most peaceful yeller in the world, okay, but just bear with me here. All right, I'm looking at most of your notes here as I'm checking homework, and I'm going to say probably half the class is doing like their graphs roughly in their notes, okay? Did I check for graph paper in this class? Yeah? Okay. Because when we get to trig, which is coming up next, we do trig graphs, you can't just sloppily do your graphs in your notes like that because it doesn't work at all, okay? So if you've been doing that, that's okay. Ask the Easter Bunny for graph paper this weekend so you can start doing real graphs in the future, okay? Make sense? Okay, because it doesn't take that long to do it on graph paper. Use a ruler, and it looks 100 times better and it's more accurate, okay? And I'm just harping on that because when we get to our next sets of graphs, they're much more difficult than this. All right, sorry for that yell in a whisper. Okay, any questions on those points there? We're good? Okay, I'm gonna graph this very quickly here using perfect graph paper. Just so you know, the computer died on me right at this point in the lesson, in my last class, so I had to graph on the chalkboard. And I know the pain that you're going through to graph, but it took me, I don't know, 30 seconds to start my graph. That's all it took at the absolute most, using a giant ruler this big. So when you guys use a small ruler, it should take you like 5 seconds to do your graph. Okay, so don't make excuses and do proper graphs, please. I don't mind. Yeah, certainly. Graphs bother. All right, here we go. So as far as this goes, I got to get from 6 and under. Okay, so I'm going to start at y value is going to be 6, and 2 and 5, so I'm going to make my line look something like this. 6, there we go. 2 and 5, it's going to look something like this. Okay, I'm going to label all the numbers. 0, 1, 2, 3, 4, 5, 6. There's my x. There's negative 1. 1, 2, 3, 4, 5. Lovely. This is y. Negative 1, negative 2, negative 3, negative 4. Okay, so I'm going to draw my points 2, 4, which is up here someplace. 5, 2, which is over here someplace. Okay, can someone please be brave, Liam, and tell me how I draw an asymptote? What does you do for that? Go ahead. So we're going to say here, this is where the graph isn't going to hit. It's going to say y cannot equal 6. I'm not going to tell the joke again. Okay, but can someone tell me how I'm actually going to draw this graph and make it look? What do I do? Yeah, it goes sort of like this. If you need a help to remind you, this graph is going to look like this. It's going to want to continue its trend. Okay, right, but it's going to hit there, so we're just going to slide it along sort of like this. Okay. It has to be a function. Okay, so it's going to continue off in that pattern. It's not going to curve around or anything. If you want to think of like a little kid going to figure skating, you can do that too. Okay, right? It's going to be a nice solid pattern there. We're not actually hitting the board with the asymptote. That's a yucky looking graph, and that's okay. Sort of okay? Makes sense? Yes? Oh, sorry, one question.
From those points, is it completely straight up until it gets
No.
to about the asymptote?
Pretty, I mean, very close to it. Like if we were to graph this, and then maybe I will a few times here, which we do, because we're talking $1 million. It's going to be, because it's exponential, it's going to be like a curve for sure. Okay, but basically it goes, yeah, sort of.
So like when it's down in like the negative 100s, right, or something
Yeah.
like that, would it just be going straight the whole entire time until it gets to the 6?
Right on.
Okay.
Yeah. Okay, like it's basically over here. It's almost horizontal. Like it's very, very, it's up like, it's like 0.001 degrees up or something, right? So, yeah, it's almost horizontal. Okay, can I get somebody brave to do domain and range? You guys are going to work here because someone normally does domain and range, but she wasn't here yesterday, so everyone else is going to take a turn here. Quinn, go ahead, domain.
Domain is everything.
Good. And Quinn, since you volunteered and didn't do your homework, you do the range here as well too.
Y could be less than -6, or it's positive 6.
Okay, now Quinn is totally correct. Why would it be incorrect if Quinn said y is less than or equal to? Turn the ladder.
Me?
Go to, yeah, Jesse, go to.
I can't touch the asymptote.
Yeah, can't touch the asymptote. Okay, so some of you on your test will say less than or equal to because you're used to that with your vertex and all that. Because you're used to it and all that, okay, but make sure. Now, for those who weren't here yesterday, does that make any sense? No. Okay, does that make any sense? You sort of happy then? Right, just getting your starting points and it's the same table we did before. Okay, good? Sort of good? Yes. All right. So today's lesson's going to be a little different than usual because we're going to do a little bit more of a discussion today. This is, I'll hit pause here for a sec. I'll